Hello everyone, this is Dr. Hira, and in this lecture, we are going to discuss organic chemistry and organic compounds. So, before starting this introduction and the introductory course for the organic chemistry, which is Chem 160, so I'm hoping that you have the information about the basic concept of the chemistry, atoms, elements, and the compounds. But if you wanted to refresh some of your basics about the periodic tables, about the trends, what are the pure substances and the compounds, so you can check out my lectures on my YouTube channel on the bonding, on periodic table, and the general chemistry courses. So we will define in this lecture that what is the organic chemistry. So organic chemistry is one of the branch of the chemistry which deals with the study of the organic compounds. And the older version or the older definition was that the organic chemistry is basically the study of some of the natural products or maybe the natural compounds which are extracted from the plants, sources, or the fossil fuels. But actually, the modified definition of this is that this deals with the compounds which are mainly the carbon based, and the carbon is having the other elements also. Largely, it is based connected with the carbon, and the hydrogen, but it do make the bonds and it is making the compounds with the covalent bonding with the oxygen, nitrogen, and the halogens. And these are also the elements which are on the periodic table. So you all know that we have the 118 discovered elements on the earth so far up to this date, and they have grouped in the periodic table on the basis of their trends and the nature. So the organic compounds and the organic chemistry is basically the dealing with the compounds which are based on the carbon and hydrogen, and the bonding type is basically the covalent bond. So you also can check the lecture on the bonding in which I have discussed the one lecture about the ionic bonding, and then the covalent bonding or the coordinate covalent bonding. So you could have the distinction and the uh, clear concept about the what are the different kinds of the covalent bonds, and when we can say that the bond is the polar covalent bond and this is the non-polar covalent bond, and one kind of bond is the ionic one. And we know the atoms and the elements do combine with each other to form the different compounds. So organic compounds are basically the compounds which are largely based on the carbon and hydrogen skeleton, and the carbon is having the strong bonding with the carbon, hydrogen, nitrogen, oxygen, sulfur, and the halogen and other elements too. So we in this course we will talk about the different classifications of the organic compounds and how do we classify these organic compounds. So I want to emphasize on this that what is the scope of these organic compounds. So organic compounds are basically everywhere you can see. So these are present in your plant, in the animal sources, and in any industry you can name. So they have the organic compounds used in that industry. Or cosmetics are largely organic compounds, or drugs and medicines are organic compounds, the enzymes, proteins in our body system, in the living systems, they are the organic compounds, paints and varnishes, so foods, they all are basically giving you the rich, and there is over 10 million different organic compounds, but different scientists have discovered and synthesized, right? So this is some of the industries I have named, but there is a very long list of this, which include the uh, fabrics, which include adhesives, which include the um, uh, plastics and the um, other flooring panels and the textile, the dyes, so anything if you can name. So there is the organic compounds which are involved in that industries. So obviously, if there is such a larger number of organic compounds, and still the scientists, the chemists are in constant struggle to generate the new compounds, the new challenging compounds. They are also going to make the compounds which are the nature inspired, because in nature, if you can see, so these are the very complex and very big molecules which the nature has constructed, which are otherwise very um, tough, very difficult, and sometimes very challenging for, and they are the scientists who are totally struggling for their total synthesis. So we get inspired with the nature to synthesize the compounds. We do create the new compounds as a chemist. So of course there was a need that we could group these compounds in some of the classification, because for a person this is not possible that you name and you remember any of all of these millions of the compounds in your memory. So what is the thing is that you need the basic information by which, by looking at the structure, by looking at some of the characteristics, so you can name that compound and you can predict it what would be that characteristics. So on the basis of that one, some of the common observations were made, and the chemists do come with the one of the basic idea that they have to classify the organic compounds in the different groups for the identification, for the convenience, as we do grouping in our daily life in the classroom subject wise. Animals are divided in different groups based on their characteristics, like reptiles, mammals, birds. They all have their own characteristics on the basis of their uh, main family. So humans are grouped on the basis of ethnicity, race, religion, gender, education, for the identification. So similarly, organic compounds have grouped into different classes for convenience, identification, naming, and characteristics. So by which we came to know that we suppose and we expect that that is the chemical behavior that compound will show, because it has that important um, site or that important group in this compound, or that important functionality, which is called the functional group. So I have placed one of my picture of the conference in which we all uh, five belong from the different regions, from the different language, from the different geographical, from different cultures. So obviously, so on the basis of some of the traits, you can expect and you can guess that what is that person belongs to on the basis of their something, the color, ethnicity, their language. So in a similar way, that is important that we can have the some of the convenient way to um, have a proper grouping of the organic compounds, as we do compile the different data for the information for convenience, that we can group that. And you used to do create different folders in your laptops, in your systems, that you will be able to see, rather to search in the whole D drive or in the whole computer system. So you can just click on that particular folder which you has named, and you are grouped on the basis of some characteristic point which we have kept as a filter. So in a similar way, the organic compounds has classified. So I hope when we proceed in this course, that would be very interesting for you, that we are starting from the very beginning, that we are just defining the organic compounds at the beginning, and then you will be able to name the different organic compounds. And obviously that is very satisfactory and very amazing, that some of you, or maybe the many of you, were just scary, and they were thinking that the chemical compounds are very terrifying, or the organic chemistry is very bore, or maybe the very tough. So there are some basic core concepts. So if you're taking these at home, and you are keeping these principles and the basics in your mind, so this is not difficult for you to name any of the bigger compound, or any of the organic compound in its chemical systematic name. So let's define the functional group, because I have told you that this classification is on the basis of the functional group. So this is the key point on which the organic compounds are grouped, and this is a base or the foundation on which the organic compounds are grouped under the different classes. So a functional group is basically made up of an atom or atoms. So there could be the single element which is giving a characteristic chemical behavior to that compound. There could be the group of atoms which is creating a group to that compound for the characteristic chemical properties. The chemistry of organic compound is determined by the functional group that are present. So you can see that what is the importance of the functional group. So on the functional group basis, we are grouping these compounds. Why? Because these functional groups are basically responsible for the characteristic chemical properties. That, for example, if there is an acid, if there is an basic compound, if there is the only hydrocarbons. So I will talk about these in detail. So I'm naming that you get familiar with these terminologies. So if these are the compounds, so as you know that what is the functionality here, so you know the functionality, and you know that what is the characteristic behavior of that functionality. So you can assume that this compound will go through that reaction, or this compound will not go through this reaction. So on the basis of these knowledge, the chemists are setting up the different reactions. They are mixing the two reagents because they are using their chemical knowledge, and they are expecting that they should combine in a way, and for a desired product they choose the two particular reagents. So this is not the haphazard. Of course the amount, concentrations and other factors are with the trial, with the setup, they observe and then they conclude. But this is not the blind hit that I can take any of the reagent and I can mix that one. So there could be the explosion, there could be the damage, and there could be that there is no reaction. So of course I have to use that knowledge of the functional group, that either that is going to react with that, or that is not going, or this is totally banned towards one of the reactant, right? So there are a number of classes of the organic compounds. So I will discuss with you, and I will show you the one of the slide in which all of the organic classes, the major organic classes are mentioned with your functional groups, right? So firstly, we'll talk about the hydrocarbons. So hydrocarbons are basically largely the sources from the petroleum, and these are the petroleum products, and they are used as a fuel. So one of the very familiar thing is a natural gas, which is a methane, and this is the belongs to the from the class of the hydrocarbon. So hydrocarbons are basically is a class of organic compound which basically having the compounds which are only made up of the carbon and hydrogen. So there is no other element attached to that one. So their structure is only based on the carbon hydrogen. So that's why they are named as a hydrocarbon, hydro for the hydrogen and the carbon for the carbon one, right? So they are only carbon and hydrogen based compounds. So but it has this some of the subgroups on the basis of how the carbon is attached to the other carbon, or you can say that on the number of the hydrogens attached to each carbon. So a carbon is basically tetravalent. Tetravalent mean that it can make the 4 bonds, right? So let me choose a pen to identify. Let this is the 1 bond, right? This is the second bond. This is the third bond, right? And this is the fourth bond, right? So if the carbon is bonded with the 4 covalent bonds, it means, so 1 bond is basically representing the 2 electrons, right? So they are the 2, 4, 5, 6, and 7, 8. So we have discussed that in our general chemistry courses, that element or an atom is having a desire to make the bonds with other atoms to complete its octet one, because that is to gain the ideal configuration. And that ideal configuration is this one, that except the hydrogen and the helium, so all of the elements and atoms are to gain uh, their respective Nobel gas configuration, right, which is 8th group element. And another way, in the simple way, I can say that they should have the 8 electrons in their outermost shell, right? So here, if you just count this one, so the carbon is having the 8 electron in its outermost shell. So this is in a stable form. So that stability uh, attained when the carbon has made the 1 bond with the carbon, another carbon, and the 3 bonds with the 3 different hydrogens, right? Because the carbon can make the 4 bonds because it has the 4 unpaired electrons by itself, which it already has in its pocket, and then it needs the 4 more electrons to complete its outermost shell. So that's why this is the one making this one. Now this is the one of the subclass of the hydrocarbon, where the carbon is attached through the single bond with the hydrogen and a single bond with the carbon, right? So all bonds are the single bonded. So this kind of subclass of the hydrocarbon is called alkane. Now, another one is when the carbon is having the 1 hydrogen deficient from the alkane one. It means that there is not the surplus number of the hydrogen. So what the carbon will do to get its stability is that the carbon will make the another multiple or the second bond with the carbon to get the 8 electron in its outermost shell. Now again, if you just look at this one, so here the carbon has the first bond with the carbon, then the second bond with the carbon, and there are the 2 hydrogens which are attached with each carbon. And as I told you, that the 1 bar in the 1 bond means that they are the 2 contributing electrons, right? So there is a 1 pair of electron. So they are the 2, 4, 5, 6, and 7, 8. So the both carbons in their ideal position, and of course the hydrogen is in its stable position, because hydrogen has to gain its electronic configuration of the helium, and helium is its ideal because it is just at the end of the 8th group and it is a Nobel gas. So it needs the 2 electrons in its outermost shell, because this is the very smallest this is the smallest element of the periodic table, and it has only the one shell. So in one orbital, there is only the maximum 2 electrons can accommodate it, right? It has only the one orbital, so that's why it just need the one more electron, because one it already has. So now through this, it is gaining the 2 electron in the outermost, but the carbon has the 8 electron in its outermost shell. So overall, the carbon bonds are the 4. Now, if we further reduce the number of the hydrogen, means one hydrogen less than the alkene, then it means this carbon will make the third bond with the carbon to get the stability, and they both will mutually share these electron with each other. So that is basically the definition of the covalent bond. So this kind of subclass where the carbon is triply bonded with the other carbon, this is called alkyne, right? So this ethane, ethene, and ethyne is basically the IUPAC name of that particular compound. And the brackets are showing the class name of these compounds. Now, if the carbon and hydrogen skeleton is in a form that this is making the 6-membered ring, and this is the closed structure, this is not the open chain structure, then these are called the aromatics, right? And the benzene based compounds. So benzene is basically the basic example of the 6-membered aromatic compound and the hydrocarbon, where they are the alternative, they are the 3 double bonds and they are in the cyclic form, right? So there's a single double CC bond, they are in the alternative positions. So this was the one of the class of the organic compound. In a similar way, we will see the other classes of the organic compounds in the next slide. But I want to emphasize here, and you should know that through the functional group, what are the information we can get about the organic compounds, or the functional group identification is enabling, or what are the benefits of this functional group identification with respect to the organic compound. So basically, the functional group gives information for the naming of organic compounds. So if there is the functional group, which is the C double bond OH is attached to one of the carbon chain, so then that will be named as ethanoic acid. If there is the only this CH3 is attached with the OH, then this is the ethanol. So we will talk about this in a detail. So right now you should remember that by recognizing the functionality or the functional group, we can name these organic compounds. And when we name these organic compounds, so from the name, we are able to see that what are the different characteristics of that compound, and we can assign it the proper systematic IUPAC name. So here, this is the ethanoic acid, because this C double bond O and this OH is basically the major functional group, which is giving the characteristic chemical behavior to that compound. Now, in the second compound, this OH is basically the functionality which is giving the characteristic behavior, chemical behavior to that compound. The rest is, this is only the carbon which is attached with the hydrogen one. And this is by mixing, when we mix these two in the acidic conditions, right? We add, for example, if we add the sulfuric acid here, so its formula is H2SO4, right? H2SO4. So if we do this reaction in an acidic condition and heat this so then what is happening here, that we are getting a product, and this product is different from the alcohol and this acid, right? So this is basically the ester. So ester has the general functional group as R. Just CH3, I'm writing R for this, right? And then there is the C doubly bonded oxygen, and there is another oxygen here which is singly bonded attached to carbon, and then there is the C2H5. I'm writing it in a condensed way to avoid the timing, right? So this is the general formula for this one. So or otherwise I can just write it here, another R, and on the place of this C2H H5, right? So you can write this one. So the thing is to emphasize is that you should know that what is a functional group. So if I say you that write the generic formula for a class, so you should know this R C double bonded O and O. This C doubly bonded O is basically the carbon doubly bonded with oxygen. This is called a carbonyl, and there is furthermore an oxygen, right? Now if you just draw the generic formula of this one, so this is basically R and there is OH. So in generic formula, what we used to do is that we just not mentioning that how many carbons are there. This is understood that if this is the alkyl group, so this R is basically give you the idea about the alkyl chain. So alkyl is a term we use for any of the carbon chain which is attached. That could be the two carbon, that could be the 3 carbon or the longer chain, right? So this is the alkyl. Now, if you just look at this one, so this is the major functional group, right? And you can write this one as, and you can write here as R. So R C double bonded O and OH is the generic formula for the acid. This is a generic formula for alcohol, and this is the generic formula for the ester, right? So you should identify, and R is simply for where there is a carbon chain, so you can just simplify, write the R if that is required, that I'm just asking for the general information. Or you just have to depict, mention only the function group. But if there is exact or IUPAC name or the particular compound has asked, then you have to draw exactly that how many carbons are there, and we will talk about these in later, that how we can name the compounds, how we can draw the structure of the organic compounds. Now as I told you, from the functional group, we are able that either we will name it as an acid, either we will name it as an alcohol like an ethanol, or we will name it as an ester. Then it is also giving us the information that how we will draw its structure. What is a connectivity? Connectivity means that either that carbon is doubly bonded with the oxygen and there is another oxygen, or this is in a form that there is R and there is the OH group. So that information you will get from the name and the class name or the end or the suffix of that organic compound. Then the third point is that the functional group is giving us the idea of the chemical reactivity, that the compounds which belong from the same class, they show that characteristic reaction. So whatever the compound is, if it is having the common and the same functionality, this will undergo through that reaction. That is another discussion, that if the compound is a very bigger or the smaller one, so there will be the rate difference, but that will go through that reaction if that functionality or the functional group or the class of that compound do exhibit that chemical reaction. So as one of the common type is that whenever we mix the acid with any of the alcohol, they are generating the ester, right? If we are not using the acid here, if we add the ester here, if we add aldehyde here, so then we cannot synthesize the ester as a product, right? So these the all classes undergo through the different kind of reactions. So from this information and knowledge, we can design that what is our desired product, or so we wanted to synthesize. So then we can go for that one. So the interesting thing about the ester is that ester are basically the flavors, and most of the essence in your food material, and even in the perfumeries. So these are basically the esters which are used because they have the very pleasant fruity smells. And so by the combination of the different acids and alcohols, the chemists do create the different esters which have their characteristic smell and flavor. Now there is another classes of compounds, and these are the one of the class is that whenever there is the oxygen based compounds. So there is many subclasses of oxygen containing compounds. So if the carbon is doubly bonded with the oxygen and their one side is fixed with the hydrogen, and on the other side there is R group, so this is termed as aldehyde. So these all are basically the carbonyl containing compounds, but the difference is that what are their both sides, what this carbonyl moiety, or what this carbonyl functional group is having on both sides. So if the one side is fixed with the hydrogen, this is aldehyde. If the both sides are sharing with R groups, so these are ketone. If the one is R and the other one is X, X is basically the generic symbol which we give for the halogen, which are the bromine, chlorine, fluorine, iodine. Then if the other side is having the OH, as I have shown in the previous slide when we were talking about ethanoic acid. So these are giving you the class, the carboxylic acid. Now the ester is when this OH hydrogen has replaced and there is another R, then this is giving you the ester. Another is the acid anhydride, and this is basically the double of that ester. So you can see if we just break this in the equal half, so there is a 2 carbonyl, which and there is a 1 oxygen sandwiched between these 2 carbonyls. So this is just extended, so you can add the one other side here. So this is the acid anhydride. Now the amides are basically when there is a carbonyl and there is the amino, which is the NH2 group is attached on one side and the other is having R. So this is amide. Now there is another class of the compounds when there is a triple bond to the nitrogen. So these are grouped and named as a nitrile. So they are also named as a cyano, and you have you know the cyanides and the hydrogen cyanide, which is a very poisonous element that's just go for the immediate death if even it is taken in a fraction. So these are the different classes of the compounds, and these are named on the basis of the connectivity, and this connectivity is basically the functional group, because then it is giving a specific chemical character to that compound. Now, this is a slide where you can see the different classes of the organic compounds. So here, if you just go at above, so the black circled and this black color is basically showing the hydrocarbon. This green color is showing the halogen containing groups, means which are the fluorine, chlorine, bromine, iodine based compounds. Then the red is for the oxygen, blue is for the nitrogen containing compound, orange is for the sulfur containing compound, and purple is for the phosphorus containing compound. So in this slide, if you just check this image and this image, so here you can see that, as I have discussed with you, that there are the 4 subclasses of the hydrocarbons. So alkanes, alkene, alkyne, and arenes. Arenes are for the aromatic, which are the benzene based compounds, right? So these are the hydrocarbons because there is no other element attached to that. There's only based on the carbon and hydrogen. So this R means R1, R2, R3, R4 are basically giving you the idea to differentiate that this carbon is attached here from another carbon chain. They could be of the same length, they could be of the different length, right? Now, this green is basically the halogen-based compound, that R is any carbon chain which has one of the halogen attached to that one. Now, this is the alcohol, this is the aldehyde, this is the ketone, and this is the carboxylic acid, this is the acid anhydride, this is the ester, this is the ether, this is the epoxide. Now, the difference in the ether and the epoxide is this one, that here the carbon is attached with the single bond to the oxygen. This is not the carbonyl one, right? Now, if you just look at some of these classes where they are the two colors have used, these are to identify that which side is showing what, right? So a half is the green, it means this is having the halogen, and the other one is having the carbonyl, which is the oxygen containing compound, and oxygen containing compounds we were mentioning with the red color, right? So this is the acyl halide. Now again, you can see this is in nitroso when the nitrogen is in a double bond with the oxygen. There's imine, there's imide, there is azide when there are the three nitrogens which are doubly bonded to each other. There's cyanate, there's isocyanate, there's azo compounds where there are two nitrogens in double bonded to each other, and from the both sides they are attached to any of the carbon chain. Now there is a thiol when the sulfur has one side hydrogen, and on another side this is attached to any of the carbon chain. Now this is the sulfide when the sulfur is just in between, and you know this disulfide bond is very important in our protein structures, and this thiol is also basically responsible for developing these disulfide bonds in our different protein structures and between the amino acids. Now this is the disulfide where there are the two sulfurs, so that's why there is a term di has used. Sulfoxide when the sulfur is combined or attached with the two doubly bonded with oxygen, just like the carbonyl, but the only difference is now that there is the sulfur on the place of the carbon. There is the sulfone, which when the sulfur is attached with the two oxygens through the double bonds. Then there is a sulfonic acid. This is just like the carboxylic acids. If we just look at this one, so carboxylic acid, this carbonyl is present, carbon doubly bond oxygen, and in sulfonic acid, this is the sulfur based. This is the another form of the carbonyl, like there is a sulfonyl which is attached, so this is a sulfur on the place of the carbon. Now there is a sulfonic acid, there is the sulfonate esters. So the only difference from the ester is that there is a sulfur on the place of the carbon. Now the thiocyanate, as there was a cyanate, right? Isocyanate, so this was the nitrogen, carbon and oxygen, and here there is a carbon, nitrogen, and there is a sulfur. This is a thio. Thio is the term which usually used for the sulfur in hetero compounds, right? So isothiocyanate, thio is for the sulfur and the cyanate is for the N doubly bonded with the carbon. Then there's a thiol, thio, tone, and there is a phosphine, which is the phosphor base, right? So this is just to give you the idea that there are the number of different organic compounds, and the carbon can make the bond with the hydrogen, carbon, and the other elements too. In this course, we will talk about generally you should know that what are the different functional groups and what are the name of these classes, right? So we will not go into the IUPAC naming of these classes as such, but you need to practice that. At least you can find out, you can identify the different functional group, and you can relate that if that functional group is present, so where you will group that compound and what will be the class name of that compound. That for your information, there is the example of each class has given here. And there is a suffix which has mentioned. Well, we will talk about this one, so don't get panic with this one, because we will talk in detail how to name the organic compounds and what are the different components of the name of the organic compounds, right? Now, for today, this is your task, that you get familiar with the organic compounds. You can define and you can identify that either the given compound is organic or this is not organic, right? So the compound which is organic is which is mainly carbon based, and the carbon is covalently attached to the other elements, right, or other atoms. So you have to check my lecture for on the ionic and the covalent bonding, right? And your task for this lecture is that then there is the thing that you can identify the functional group, you can name the classes of the compounds on the basis of their functional group. So that is just the task, which is the reflection that either you are able to get that concept of the organic compound and the functional group and the classification of organic compound. So that is a task which you have to submit on a Moodle. Is the first part is that you have to list any 5 organic compounds. So I'm not expecting here that you can name the IUPAC name. So if someone can do it's fine, but I'm more interested that if you know some of the compounds, either you know their common name, but they should be organic in nature, they should be organic compounds, right? I have named the industry, so that is a hint for you that you can search out. And there's only the 5, there are a number, millions of compounds. You can name any 5 organic compounds which could be natural, which could be synthetic. So just search out these one and just do a little work on it. So the one example I have given, like a vinegar, which is an acetic acid, or you can say this is the ethanoic acid in your kitchen, in your different food items. So you can just name like this one as a common name. The second part is this one, that you have to write the class, identify the functional group, and you have to write the class name of these 3 compounds, right? So write the name of class of following compounds on the basis of functional group. So firstly, you need to identify the functional group. What is functionality? The major functional group, but by which the one compound is different in chemical nature to other. Otherwise, of course, there is a difference in the carbon chain. But what is the characteristic and the unique thing which is which will give it the different chemical behavior? So you will encircle the functional group and then you will name that class of the compound, right? So I hope you get an idea. So you can submit that on Moodle, where I have mentioned the deadline, and I will open the assignment tab on the Moodle, so where you can submit it in a Word, in an image, and in a PDF form. So what is convenient to you. So take care. Thank you for today.